In this video, we'll discuss substitution rule one more time. We will try to do the substitution rule for the definite integral, right? The example we have before is the substitution rule for indefinite integral. And so this time we try to see how do we handle definite integral using the u-sub method integral. Again here, right, we need to assume our function is continuous and everything works, right? So, we have some assumptions. Suppose the inner function g prime of x for sure differentiable, right, is continuous on A, B. And also f is continuous on the range, because it's a combination of two functions, range of g of x, right? And now we can do the substitution now. So if you have integration from A to B, f of g of x times g prime of x dx, right? So this might look very bad if your inner function is complicated, right? So remember what's the meaning of this lower bound, upper bound. So that's the lower bound, upper bound of x, right? X is changing from A to B. So that should be complete name, should be x equal to A to x equal to B, right? So when you do a substitution, as we did, you introduce a new variable, which is u, right? U here equal to g of x. Then du here is g prime of x dx, right? And now we can do the substitution here, integration f of u du, right? But x is from A to B. What's the lower bound and the upper bound of u, right? This integral here will be, this should be the lower bound of u. This should be the upper bound of u, right? So corresponding to x, you can do a substitution here. When you have x equal to A, you get u equal to g of A, right? When you have x is B, and u equal to g of B. So this should be g of u, g of A, g of B. So that's the lower bound and upper bound of this new integral, right? So let's see a couple examples on how do we use this method to evaluate some definite integrals, right? So let's see the first one here is integration from 1 to e natural log of x over x dx, right? Okay, how do we handle this, right? So we want to introduce a u whose derivative is included in the integral, right? This one is kind of we can see that clearly because the only two functions involved, 1 to e, get natural log of x times 1 over x dx, right? So this hint should be what? The u should be natural log of x because that derivative is in there. So we let u here equal to natural log of x, and du is 1 over x dx. For this new variable u, we also want to figure out the lower bound and upper bound, right? So when you have x is 1, u is natural log of 1, which is 0. When you have x is e, u is natural log of e, which is 1, right? So let's do the substitution now. So integration from 1 to e natural log of x times 1 over x dx. So this is equal to lower bound will be 0, and upper bound is 1. You get u times du, right? So this is the antiderivative of u is u squared over 2, then you plug in 0 and 1. So this is 1/2 minus 0. So this is the final answer for this problem, right? Okay, so this is how do this example shows how do we use u-substitution to solve some definite integrals. So now let's see another one. The second example here is integration from 0 to pi over 2 sine of x over 1 plus cosine square of x dx, right? Okay, this thing here, you can try different substitutions, right? You can try it, right? The only way to make it work is just try it out and see which one works, right? But if you look at the sign here, right? Look at the bottom here. The bottom contains cosine. So the derivative of cosine is negative sign, right? So a possible substitution will be let u equal to cosine x, right? Let's try to see whether that works. So if you let u here equal to cosine of x, then du is, as I said, negative doesn't matter. You can always put a negative on the left side and do the substitution, right? Sine of x dx. Now let's try to see the lower bound and upper bound of this new function. We'll have x is 0, and then u here equal to cosine of 0, which is 1. When you have x is pi over 2, u is cosine of pi over 2, which is 0, right? Okay, now let's try to do the substitution. Before we do that, we just make it easier to see what's the substitution times sine of x dx, right? So this is integration. Now let's do the substitution, right? It's from here to here, we are doing the u-sub. Lower bound and upper bound go from 0 to pi over 2 to 1 to 0, right? This is 1 over 1 plus u squared times -1 times du. -1 really doesn't matter, take it out. So this is negative integration 1 to 0, 1 over 1 plus u squared du. Oh, we know this function here. This is the antiderivative of this function is arctangent, right? So this is negative arctangent of u, then plug in 1, plug in 0, do a subtraction. So this is negative arctangent of 0 minus arctangent of 1, right? So that's basically how do we evaluate this definite integral using the method of u-substitution.